Hi dears, welcome to math class. Our title is Algebraic Factoring 2. Factoring expressions or statements factoring expressions that have the following form. Factoring expressions that have the following form: AC plus BC plus ED plus BD. Already in factoring number 1, we see that if there is some statement, in all of them there is a common, or one or two or three common letters. But here is not. Here is A, here is A, but there is not A. Here is C, but there is not C. D, in these two terms there is no C, D. But what we do, we solve this kind of problems like this. We separate into two groups, this 2 and this 2. Now this one, the common letter is, or common factor, the common factor is C. When we remove C here, put it out, what remaining here? It is AC. AC is out. Now the term A is A plus, and the BC, C is out, B. In these two, we see the common factor is D. We take the common factor outside, then here is remaining A plus B. Now what we do? Now when we use the method of factoring number 1, there's two binomials common factors, A plus B is one in one parenthesis, or what is it here? C plus D. Now we factor this one into two parentheses, or two factors. Now I solve for you some examples. Example: factor Factor means factor the following statement or following expression. Three AP plus 6 BC plus 4 AD plus 8 CD. Now again we separate 2 by 2. Here this one, we separate those two if there is not common factor between the two. We do not do it. Otherwise, we should arrange or organize it. Here, between 6 and 3, the common factor is equal to 3, and here B. Now 3 is outside. Here remaining A plus 6 divided by 3 is 2. We put B outside, 2C plus between 8 and 4, the common is 4 and also D, 4D. Here we remove 4 outside, we bring 4 outside, and also the D. Here is remaining only A plus 8 divided by 4 is 2C, because D is here. Now what we do, we put it into two factors. The one common factor is A plus 2C, A plus 2C, and the other one is 3B plus 4D. D. Okay, now I solve another example for you. Example, factor. Factor means factor the following expression. Three x to the power of 2 minus 3xz minus 4xy plus 4yz. Now again we separate 2 by 2 terms, these two and these two, and we find the greatest common factor between them, or GCF. The greatest between two numbers, 3, and the x power of 2, and x is this common factor is x, and this is enough. Now what we do, 3 by 3 divided by 3 is 1, 1 times x to the power of 2 minus x to the power of 1 is x to the power of 1, or x minus z. You already removed the 3x. Now here the common factor is 4y. 4y here, and now 4y is out, or we remove it outside. The only thing is remaining is x. Now here we know from the putting and removing from the parentheses in the law from that lessons, that if we bring something into parentheses with a negative sign, the inside changed their signs. Now it become negative. Again, like negative times negative become positive. Z. Between these two terms, according to identity number 1, the common is x minus z, common factor, and the other one, another factor is 3x minus 4y. If we multiply these two factors, again give us the same statement or expression. Now I solve another example for you. Example factor. A to the power of 3 x minus a to the power of 2 b times x minus y minus ab to the power of 2 yz y minus z times, or negative b to the power of 3 z. We see that there is no common factor and there is no the similar terms. For this kind of statements, what you do first of all, because this is unassembled, to assemble this one we should simplify this one. A to the power of 3 x minus negative term, like positive is negative, a to the power of 2 b x. Negative times negative is positive, a to the power of 2 b y. And here negative times positive is negative, a b to the power of 2 y. Negative times negative is positive, a b to the power of 2 z minus b to the power of 3 z. Now we see there are 6 terms. We simplify these ones. 2 by 2 in this one, a to the power of 2 is common, a to the power of 2 and x, but not b, because here is b but here is not b. Thing is, a to the power of 3 minus a to the power of 2 become a to the power of 1 minus a to the power of 2 is outside and x is outside, b. only numbers remaining is b. Here a to the power of 1 is common. We take the smallest one. B to the power of 1 or b, y. Now a to the power of 2 minus a is a, b and y is outside of the parentheses, minus is here, b to the power of 2 minus b to the power of 1 is equal to b to the power of 1 or b. And between these ones, b to the power of 2 and z is common. The thing is remaining is a minus b to the power of 3, and to the power of 2 is b to the power of 1. In all of these three terms, according to identity number 1, the common is a minus b. We see that here is a minus b here and here. Now the thing is remaining is the statement is a to the power of 2 x plus aby plus b to the power of 2 z. We should factor these statements by the time that is possible to factor, and we should go forward. But here is no common, but in this one here is a, but here is not a, x not a, there is no common factor between them. I think this is the final result, and this is enough for today. Thank you for watching our video. Please don't forget to like, subscribe and share the video with your family and friends, and please press the notification bell to get notified for more videos. Have a wonderful days and nights. Bye bye.